Aloha and welcome. In this video, we're going to be talking about code review, fuzzing, and automation. So when you're developing software, you do this in teams most often, and that really does vary between the different size companies that you work in. Smaller companies, you may be wearing more hats. Larger companies, you may be just one cog in a much larger machine. But in these different companies, you will come across something called code review. And code review is the process of systematically examining the code that has been written with the aim of improving the code quality. So code review, it's going to examine the code's correctness, its readability, and its understandability. So you've got two different methods here. You've got dynamic code analysis and you've got static code analysis. So dynamic code analysis, also known as dynamic analysis, it's a code review method that examines the code while it's executing. So dynamic code analysis is commonly automated and it's performed by using test inputs that aim to cover all possible outputs. Using dynamic code analysis, you can find out like what sections of codes are taking the most execution time and things like that. So we also have static code analysis. That's also called static analysis or source code analysis. This is the review method where you're just looking at the code. You're not executing it, you're just looking at the code itself. So static code analysis is performed by analyzing the code against a set of coding rules and can be performed manually or you can use automated tools. So manual code review is the process of performing the static code analysis by one or more code reviewers. So actually getting people in the process here. So in addition to code review, comprehensive approach to this code-based security, it involves proactive management of dependencies and third-party libraries. So when you're developing stuff, you don't always just use your own homegrown code. You're often using other packages and third-party, libraries. So you also need to be wary of their, packages and everything. And if they've updated their packages, you need to look into, updating your use of them and see if there's any impact on what you're doing. Make sure that no unexpected behavior comes about. But you always want to try to incorporate the latest packages they put out because they often address security vulnerabilities. So not only is it your own code that you're reviewing, you're also reviewing your dependencies there, the package monitoring. So we also have something called fuzzing, and dynamic code analysis tool. Uh, uh, they use fuzzing, and they do that to find errors in the code. So fuzzing, I mentioned this in class the other day. Fuzzing, it's also known as fuzz testing. It's an automated software testing technique for finding software bugs and vulnerabilities by feeding invalid and random data into the software. So the aim of this is to ensure that the software can handle unexpected or crazy inputs that you throw out there, just throwing everything at it. The idea of throwing spaghetti at the wall and seeing if anything sticks. So a fuzzer is a program that automatically generates the random data for software testing. And by generating these random inputs instead of deliberately designed inputs, a fuzzer can potentially find input combinations that are not tested by the software's developers. Because when you're developing software, you're looking for your regular cases, your error cases, and your edge your edge cases, ones that fall along the, different limits that you have. So fuzzing kind of just throws everything at it and, just tries to break it in areas that you haven't thought about, protecting against. We also talk about automation. You've probably heard of DevOps. Ops is a nice, word that's tagged onto everything. You've got security operations, so SecOps. So development operations or DevOps. It's a set of practices and tools that automate and integrate software development and IT operations. So the goal of DevOps is to improve your code, your building, your testing, your releasing, your deploying, and your monitoring of elements in the SLDC, the software development lifecycle. So DevOps facilitates faster and more frequent software deployments, which is the goal of this. You want to get software out there. You want to be integrating new changes into it. You want to be deploying those as fast as you can. You want to monitor the results of it. So we have a number of terms out here. First of all, just know that DevOps uses tools to automate the manual process. So you want to take those repetitive tasks and you want to automate them as much as you can. There's a lot of scripts out there written in languages like Python that help you do that. So there's different phases here of DevOps. You've got continuous integration. That's practice of merging new and modified code from multiple developers into a single software project. Then you've got continuous delivery, and that's the practice of frequently releasing new software that is ready to be deployed into a stage environment. You've got continuous deployment, and that's the practice of frequently deploying the new software into the production environment. Remember, we talked about the different environments that you have. That's going from your, that's going and taking it and putting it into that end area, the production environment. Then you've got continuous validation, and that's the practice of frequently verifying that new and existing software is tested. Then you've got continuous monitoring, and as we talked about before, that's the practice of frequently monitoring release software to detect errors, security risks, and compliance issues. So one thing you may see out there in software circles is the concept of CI/CD. Usually that's the continuous integration, continuous delivery or deployment aspects of it. So that's it for this video. The main points here are that we have code reviews. Code reviews have, the aim of it is to improve the code quality. You can use dynamic methods. You can use static methods in doing that. You want to manage also the third-party packages that you incorporate into your software. And in testing, you want to do fuzzing. You want to be throwing everything but the kitchen sink at the wall and see if anything sticks there. And you use a fuzzer to do that. Also, we talked about automating the development process, doing things to help us, deliver software changes as quickly as we can through continuous integration, delivery, deployment, validation, and monitoring. So that's it for this section. If you have any questions, feel free to reach out. Happy to help. Aloha.